This evening I'm going to plan on giving this old Philips CD100 a bit of a restoration. I actually bought this CD player from a friend of mine who I used to work with about 30 years ago, and he bought this CD player brand new. This is Philips CD100. I think it was one of the first models introduced in the UK. Very early technology. Has developed a bit of a cult following, and I've had this CD player ever since, but it's been actually around my parents' house, being stored in their house, and they asked me if I wanted to pick it up. So I've picked it up this evening, and it's been, as it's been stored, it's pretty grubby and filthy. So this evening was going to be give it a bit of a clean up, see if we can make sure it's still working okay, and possibly give the capacitors, the power supply, a recap. This is all pretty early technology. I think it's well, it's obviously 16-bit, but I think it's 4 times over sampling, and it's in pretty nice nick. It's dirty, and I haven't used it for properly anyway 15-20 years. Often if I go around I just plug it in briefly just to see if it powers up. And I powered it up this evening, and initially nothing happened, then it all came to life, so I'm thinking that the power supply is on its way out. So the plan is to have a look at this and see if we can get it working. Okay, I flipped it over. Let's look at the bottom of it and have a look inside, see what we've got. And it's never been taken apart by me. I seem to recall that the owner who had it before, it did stop working on him. This was back probably in the late 80s. It stopped working on him. He sent it to Philips to be serviced, and they did something to it. I think they did something in the power supply, and sent it back, and it obviously worked fine ever since then. So that's the inside here, and you can see it's got the linear power supply in the corner here. This is all obviously all the electronic side here. There's the transport mechanism all open. So we need to get the top off it, and we certainly need to first of all find the power supply, which I assume is around the back here where all the heat sinking is. Get into there and see if we can find where the capacitors are on the power supply. Okay, the cover just lifts off, and you can see how filthy and dirty it is where it's been sitting around collecting dust. So we need to give all this a clean up. This is the laser and the capstan, and it's just absolutely full up with dust, so I need to clean all this off. But it's in nothing's been leaked into it or anything. I mean, I really don't know the history of it. The last 15 years I've been out of touch with this, but haven't had it near me or to cosset it over or anything like that, so I think it's just been stored and left to sort of collect dust. But I powered it up, as I say, and it did briefly work, but it all underneath all looks clean. There's no signs of any sort of distress from any power supply or anything. It's all not discoloured or anything like that. So we need to get these covers off and start tracking down the power supply, and let's get on with that. Okay, that looks like the power supply there, the main smoothing. As I say, it's all linear, but it's got some electrolytics here, so these are the ones I'm interested in. I want to check their value. I'll probably just replace them anyway. This power supply tends to run pretty hot because it's linear, so we want to get these caps out, put them on the ESR meter, have a look, see what they're like, and go from there. There's a bit of muck and stuff on the circuit board around here that you can see. So you can see it's a bit gungy around here, but it's basically, I think most of it's just dust. We can always just wash this off with isopropanol if it's dirty, but let's get those caps out and get them checked. Well, I've spotted something quite interesting here. I've just gone to lift the motherboard out, undone these 4 screws that come on here, and started to lift the board out, and thinking, well, how do the transistors, the output transistors, which are here, bolt to the heatsink? And when I looked, obviously when it went for repair, they haven't put the screws back in the heatsink, so all the heatsink's doing is resting on this outer aluminium heatsink here, and not bolted to the thermal plane. And that's Philips for you. This is Philips who did this. So they've taken it out, obviously had the board out, and not put the screws back for the heat sinks. So it's amazing that the transistors haven't overheated. So that goes to show, you think you're going to take it to somewhere decent, have it done professionally, and they don't put half the screws back. As I say, this has never been apart by me. It hasn't been apart since I bought it off the person I bought it off. So it's totally down to Philips, you know, for not doing the job properly. So let's get the board out. Move the camera up a bit so you can see what's going on. Lots of connectors and things still connected. Trying to work out how we can get this apart without disconnecting everything. I think what I need to do is take a photograph of the connections to the driver board. Let's just raise the camera up a bit. Take a picture of these connections on the board. Okay. Multiple sort of edge connectors to the servo board, need to be disconnected. Various wires. Okay, let me get this apart and we'll carry on. I'll just sum up to see what these capacitors are actually testing like. These are the two 1500 microfarad to 25 volt. I'll just pop them on the meter to see what they look like. And we'll test them at 120 hertz, so that's nearest to the mains frequency that we can get. And that's measuring 1300 microfarad. And it's climbing about 5.7 ohms. So not too bad, but not great. This is the second cap. And the ESR on this one is 6 ohms, 6.5 ohms. And the capacitance of it's ranged about 1600 microfarad, so that's not too bad. That's got a bit of life in it. Now the rest of them are, there's a 3 here which are 2200 at 16, so let's try this one. There you go, that's 812 microfarad, so it's 75% down, isn't it? Something like that. Where are we? Sorry, range. Okay. So it's 10 ohms, so that's high ESR as well. Let's try the next one. Yeah, it's about 8 ohms and measuring, yeah, about 950 microfarads, so same, very low, lost a lot of its value. That's the last of the large value capacitors. 890. Yeah, it's very much the same. They've all lost about the same rate by the looks of it. So let's have a look at its. Yeah, and about 8.8 ohms, something like that. So those caps had it. Definitely the higher value ones definitely need replacing. This is another one that I took off the power supply that was right next to the heatsink. It's 100 microfarad at 10 volt. Let's try that one. ESR of 300 ohms. That's open, isn't it? And the capacitance of 88 microfarad. So yeah, that's very suspect, that one. The last capacitor I replaced, this was I think it's 100 microfarad at 20 volt. Yep, 100 microfarad at 20 volt, or 25 volt probably. Yeah, 25 volt. Now you expect these smaller values to be lower ESR. Let's measure the capacitance first. 13 microfarad, okay, and an ESR of 750 ohms, basically dried up. So it's well worth changing those capacitors, and let's see what it does. Right, it's back together again. Let's power it up, see if it still works. That's one thing it didn't do straight away. The display didn't come straight up, so that's good. It's filthy actually, this thing. I didn't realise how dirty it was. I did actually remember now lending it to a friend of mine. And he had it for a couple of years, and I just wonder if I never cleaned it when I got it back from him. Okay. CD drive's not moving. Good start. Okay, so turn it off again. Just check to make sure the spindle's free, which it feels like it is. So just get underneath again, have a quick look to see what's going on there. That's the motor. Definitely plugged it in. Trapped any wires or anything? It looks right. I'll tell you what that could be. It could be the positioning switch might be messing around there. I know the switches can be problems on these. The lid switch. Just power it again. The motor works because I just saw the motor jump round. Could actually be the motor, the lid switch. Yep, no movement then. Come on. Oh. Okay, what I will do is I'll let it dry out a bit because I'll clean it out with isopropyl. I wonder if I haven't dried the board out. So let's give it a bit of a chance to dry out and try it again. Okay, some considerable time later, let's try another disc. It looks like it's playing, but I can't have no audio. So there's no audio at the moment. Now this is actually a disc, a pre-recorded disc, so it might not like this. Let's try another disc. it certainly finds all the tracks and reads the table of contents, so that's a good sign. It obviously just the laser's working fine. You can see it's found 14 tracks. No audio. Which is strange. Definitely got amplifiers differently on. Okay, I think this board's still wet. Okay, well, I think we're back and running. Okay, what I'm going to do, I don't want to run that for too long because I'm pretty bound to get a copyright. I'll put some of my computer music on here. That should prevent copyright. Hopefully it'll play this now. Okay, that's... Find some uncopyrighted material. Not having much luck on this disc either. Let's try this. They'll copyright this one. So there we go. It's up and running. Thanks for watching.